Okay, we're going to move into absolute value stuff, and we're going to start off with solving absolute value equations. Okay, but I have to make a really important statement before we even jump into this here. When we're solving absolute value equations, you got to remember something. Absolute values the same way that algebra steps that we would do normally to solve absolute equations. Our goal from the beginning is the way we can eliminate the absolute value bars so we can do regular algebra. Okay, now we're starting off with a really simple problem here. I want you to think about the way that absolute values work, first of all. So everybody just click on your mics here real quick. What is the answer to the absolute value of 3? Somebody just pop up real quick. 3, good, okay. So it's 3, isn't it? The absolute value of 3 is 3. That's it, okay? What about the absolute value of negative 4? Positive 4, good. Okay, last one, absolute value of 0? 0. Okay, so that really sums up the behavior of absolute value right there. It's if we input a positive number, the absolute value takes a coffee break, doesn't do anything, right? If we input 0, doesn't do anything. The only time the absolute value really has to do any work is when I input a negative and then it makes it positive, right? Okay, so then I want you to think about this equation that we're solving up here. If the equation is the absolute value of x, now x is a variable, right? It could maybe have more than one value that would work. What are the values of x that would make this true? What could I plug in for x so that its absolute value would be a positive 8? Think about that one. Paige, do you have any ideas? Can you give me one? Negative 8. There you go. That's one thing I could plug in. Very good. So one possibility would be x equals negative 8 because the absolute value would make it positive. What's the other possibility, Andrew? 8. There you go, right? Okay. So that's I'm sorry? I am actually. I'm recording with Screencastify. It seems to do a better job and it doesn't kick people off. So I am recording. Let me double check that I am. Yep, I am. Mm-hmm. Thanks for checking though. So there's a really important result there, right? If we have an absolute value of something is equal to a number, we automatically know that the two solutions we're going to get is when whatever I'm taking the absolute value of, in this case it was just an x, either equals the negative number or the positive number, right? Okay, let's apply that thinking to a different problem. I want to skip through this. Let's look at this one. Okay, so, oops, here's what I want. Let's look at this problem for a second. Okay, so what if I've got an absolute value that looks much more complicated, right? It's not just the absolute value of x. This time I've got 4 times the absolute value of this expression, negative 2x minus 6, all minus 2 equals 38. That looks a lot tougher, and it is a little tougher. Well, you'll see it's not that bad though, right? Okay, what I want you to do first of all is I want you to just think about that you have to remember the fact that we cannot do normal algebra. Don't you want to just distribute that 4? Doesn't that just seem like that ought to work if we just distribute the 4, right? Wouldn't it be nice? It doesn't work that way though. If I could just distribute the 4 and combine like terms, that's regular algebra. But these absolute value bars, they mess things up. You cannot do that stuff. So the first rule is you have to just ignore what's inside the absolute value bars. You can't even think about it for a while because if you try to do something with it, you're going to mess up, right? You're trying to use regular algebra where you can't use regular algebra. Okay, so let's do this. I'm going to cover everything inside the absolute value bars up. I'm going to call that whole thing, instead of it being some complicated expression like 2x minus 6, I'm just going to call it u. Okay, just treat it like one single thing, like a u, like before we had the absolute value of x. Now we know that it's not really a u, it's actually a negative 2x minus 6, but we don't have to worry about that for now. Okay, so my goal is First thing I want to do is I want to get the absolute value by itself. Okay, that's the first thing always to do. Step number one when we're solving absolute value equations. Come on, gosh, this board is really not working very well. I don't know why it's not. Oh, well, anyway. Step one, there we go. Step one is isolate the absolute value first. Okay. So now I want you to think about this like one big variable, right? The whole absolute value thing. It looks complicated, but we'll just call it red bubble. Okay. So we've got this equation 4 times the red bubble, which contains the absolute value. And we don't even care. We're not even going to focus on that part yet. 4 times red bubble minus 2 equals 38. What are the steps to get the red bubble by itself, right? What are the 2 things we'd have to do algebraically to get that red bubble by itself? What's the first thing we're going to do, Ann? Add 2 to both sides. Perfect. Okay. So the very first thing we do is we're going to add 2 to both sides, right? To get, and here's my red bubble again, right? Here's the red bubble we're trying to isolate. If we add 2 to both sides, that helps. Look, we end up getting the 2's cancel and I get a 40 on this side. Okay, what's the next thing we need to do, Brooklyn?
Divide by 4.
Divide by 4. Good. And then we're there, aren't we? So now we've got the red bubble by itself. If we just divide each side through by 4. That's hard. I didn't leave myself much space here, but I'm trying my best. So if we divide that by 4, we divide that by 4. Look what we get then. Then we get the red bubble by itself, and it's equal to 10, right? Well, it's not really a red bubble. It's an absolute value of some stuff. Now, what did we do before? If we look back at our previous example, when we had an absolute value of something equal to 8, you pretty much immediately told me that the answers had to be either what's inside the absolute value, which was an x, equals -8, or what's inside equals +8. The same thinking applies here. So now what's inside, we'll call it a u. Darn it. What's inside either has to equal -10 or, and by the way, this is just my fancy math way. My fancy math symbol for or is just like a capital V. Okay. Either what's inside equals -10 or what's inside equals +10, right? Just like before. But now we got to think, okay, now that we got rid of the absolute value bars, we remember that what's inside is really a -2x minus 6. So I'm going to get rid of this stuff. And once we isolate the absolute value, whatever was inside, we're just going to set that equal to the negative or the positive. And now look what we did. We no longer have those absolute value bars. Now we've just got regular math to do. Yeah, we get 2 equations, so that's a little bit tougher now. But the math is simple. Once we get rid of the absolute value bars, we can do our regular math and just get answers, right? So we could add 6 to both sides here, right? The 6's cancel. I get -2x equals -4. If I divide each side by -2, one of my solutions is x equals 2. The other equation, I'll do the same stuff. If I just add 6 to both sides, I get -2x equals +16. Divide by -2, and my other solution is x equals -8. Make sense? Okay, so let's summarize what we did. It's really not that big a deal. What we do when we're solving an absolute value equation, first thing we do is we're going to not touch the absolute value at all. We're going to isolate it. And then once I get it isolated, whatever number ends up being on the other side, we're just going to set what's inside the absolute value equal to the number or its negative opposite, right? And then just solve the regular equations. Piece of cake. Now, the last thing we want to make sure we do here, though, and you'll see why in a little bit, we always want to check to make sure our solutions are valid. Where would we check? We just go back to the original equation and plug them in. Let's just try one of these. What if I plug in -8, for example? If I plug -8 into my original equation, let's just verify that that's going to work. I'll get rid of all these things. How about? If I plug -8 in, let's see what we get. So I get -2 times -8 is 16. 16 minus 6 is 10. The absolute value of 10 is 10. 4 times 10 is 40. Minus 2 is 38. Check, it works. I would just do that for both solutions. Okay. How we doing here? Thumbs up, thumbs down, thumbs sideways. How we doing on this stuff? Okay. Okay, good. All right, let's try another one. Actually, maybe I'll do one other thing real quick before we go any further. I want to kind of show you a visual way of seeing this, what's going on. I want to spend a lot of time on this, and we'll come back to this idea. So if this doesn't sink in completely, it's okay. We'll talk about this concept again and again in algebra. But one way we can do this, if we're trying to absolute, is let's think about what does an absolute value graph look like. Okay, an absolute value graph just looks like a V, and we'll talk much more about that later in the year. It's a V, the vertex is at the origin, the right leg of the V has a slope of +1, and the left leg of the V has a slope of -1. Okay, if we're trying to solve an equation, like let's just say we've got something like the absolute value of U equals A. Remember, U might not be a U. It might actually be some expression with X's in it. And A is probably some number, right? If we can get it to that point, then what does this mean? Well, whenever we're solving an equation, there's a graphical trick for this. We can make two graphs. We can set the graph of the left side equal to the graph of the right side, and those two things are equal wherever those graphs intersect. Okay, give me a thumbs up, thumbs sideways, thumbs down if you remember ever talking about something like that. Like when you're trying to find out where two graphs are equal, that's going to happen where they intersect. Okay, you may or may not have heard that stuff before, but I bet at some point you probably talked about that in a math class. So we've got these two equations then. We've got the equation y equals the absolute value of U, which is the red graph, right? And then we've got this other graph, y equals some number, y equals A, for example. Well, what does the graph of y equals a number look like, right? Isn't that just a horizontal line? Remember that from Algebra 1? It's just a horizontal line with a y-intercept of that number. So here's my line, let's say y equals A, right? And here's my graph of y equals absolute value of U. And I'm looking for the intersections when I want to solve this equation. Well, here are the intersections, aren't they? Right? Here's the two intersections. If the height of this line is A, well, doesn't that mean because the slope is 1, doesn't it mean that I'd have to go over horizontally as far as I go up, right? So if the x coordinate is A, then the y coordinate is also going to be A, right? Same thing over here. Now the slope is -1. So if the y coordinate is A, and we know that y is equal to A, to get there, I would have to go backwards A, right? So my coordinates would be -A, +A, right? We're looking for the intersections because those are the places where the two graphs are equal. And we just see this. We can see that the absolute value of U equals A in two places. It equals A here at this X value. So if I'm just looking at this on a number line now, right? I'm just looking at this on the X axis. I've got this one point with an X coordinate of -A, and I've got this other point with an X coordinate of A, right? Those are my two solutions. So that turns into U equals -A or U equals A, okay? And that's always going to be true, right? That's something we know in math, that if the absolute value of U equals A, then either U equals -A or U equals +A. Those are always going to be the solutions. Whatever's inside the absolute value either equals the negative number or it equals the positive number, okay? Let's look at another example. How about this guy? So let's solve this one. We've got a complicated looking absolute value function here, but just take it step by step, right? Inch by inch is inch, yard by yard, it's way too hard. You got to take it in small steps. So what do we do first when we're solving an absolute value equation? What do we do first here? Caleb, do you remember? Can't hear you. Click your mic on.
My mic wasn't on.
There you go.
First, we're going to subtract the 11.
Okay, good. And what's the reason you're doing that? You're trying to isolate what?
We're trying to isolate the absolute value.
Perfect.
11,
Good.
and then we'll divide both sides by 2.
Perfect. Good job. Okay, so here's the absolute value that we're trying to isolate, right? There's our red bubble. And so Caleb's correct. That means if we're going to isolate the absolute value, we're going to subtract 11 first. So those guys cancel, and we get 2 times our absolute value. I'm not even going to write what's inside because we can't even look there yet, right? So I get 2 times the absolute value equals 68. And to get the absolute value by itself, he was correct. We're going to divide each side through by 2. And now we're there. Right now we've got our absolute value isolated. The absolute value is equal to, what's that give me, 34? If I take half of 68, right? Okay, so if this is true, now what's inside? Well, what's inside is a 2x minus 20, right? Whatever's inside, let's think about that as being inside the yellow bubble. Whatever's inside could equal what 2 things? That's my next question. Elijah. I isolated the absolute value, so what's inside is equal to, give me one thing it could equal. What's one thing that 2x minus 20 could equal? Negative what? How'd you get 79? Now think about, have you pause for just a second, right? We know that if the absolute, let's go back to this slide for just a second. If the absolute value of something, call it u, is equal to a number, then either what's inside, which is just a u, we'll call it, equals the negative number or it equals the positive number. Okay, so what's inside here? What's our u? Well, it's a 2x minus 20, right? So either that equals what? Here's the number that's outside, right? So what's inside either has to equal the positive or what? Either it's going to equal positive 34. So we got 2 possibilities. And how come that's true? Because if 2x minus 20 equals 34, then the absolute value of 34 would be 34, right? What else could 2x minus 20 equal so that its absolute value is negative, or is positive 34? Sorry. You want to tackle that, Elijah, or you want to pass on that one?
I mean, no one wanted the absolute value of 34. I thought he wanted 79.
Okay, so maybe I need to go back up here a little bit. So we started, okay, you're right. Okay, look, there's a 79 there, right? But remember what our strategy is. To solve this absolute value equation, the first thing we have to do is we have to get the absolute value by itself. It's not by itself. Right now, the absolute value is being multiplied by 2, and we're adding 11 to it, right? So we're going to get the absolute value isolated, we got to get rid of that 11. So we subtracted 11. That was good. And then we had to divide by 2 after that, right, to get rid of the 2. And when we did that stuff, we ended up with the absolute value by itself equals 34. Okay, so once we isolate the absolute value, now we're going to make our trades, what we're going to call this, right? So Guinan, said that right, didn't I? Did I say that right? Guinan? Is my mic not sounding very good?
Yeah, you said it right.
Okay. Does my mic, give me a thumbs up if my mic has sounded great the whole time, and give me a thumbs down if it hasn't sounded great the whole time. Okay, so I'm going to try something here. I'm going to try using a different mic, and you guys tell me if this is better. And I just want to do whatever's going to be the best on this. Okay. Let me try another one here, just to see if this is better. Okay, is this better? Or is it still not so good?
The other one was more clear when you were talking, but it was either really clear or you couldn't hear it.
Okay. How about this one? Does this one crackle sometimes and go out, or does it seem to be working the whole time? It might just about the same. Okay. 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 Well, if it's about the same, I'm going to try the other one should work. I'm going to go back to it. It might just be like a bandwidth issue. If it starts getting crackly again, tell me. Okay. Okay. So, Guinan. So I want to know now if we isolated the absolute value. So whatever's inside has to be equal to only two numbers if the absolute value could equal 34. Whatever's inside could equal positive 34 because that would work, right? The absolute value of 34 is equal to 34. What else could the stuff inside equal? Oh, looks like you froze, Guinan. Can you just type it in the chat? Hey, Jack, what about you? Maybe you got a better connection. Negative 34. You're right. Okay.
Negative 34.
There you go. Perfect. Okay, so those are our two possibilities. Either 2x minus 20, whatever's inside, has to equal negative 34, or whatever's inside has to equal positive 34, right? Because its absolute value is 34. So that's the trick. That's the only really tricky step in this, right? It's not that tricky. We're going to isolate the absolute value, and then whatever's inside either equals the number outside or it equals the negative opposite. And now we get these two simple equations to solve. These are a piece of cake, right? What are the steps I've got to go through to get the x by itself here? Cadence, what's the first thing I've got to do to get that x by itself over here? I'm trying to isolate the x in this equation. You can type it in if you can either use your mic, Cadence, or type it in. I don't care. Got to get the x by itself. What am I going to do? Okay, Crystal, what about you? I think we're having some technical troubles here. Can you tell me what I got to do to get that x by itself?
Plus 20 both sides.
Good, plus 20. Okay, so I'm going to add 20, and that's canceling the 20s, and then that gives me 2x equals negative 34 plus 20. That's negative 14, isn't it? And then last step, Crystal, while I got you, feel like you got this. To get the x by itself?
Divide by 2.
Good. Divide by 2. And that gives us our answer. So one solution is x equals negative 14 over 2 is negative 7, right? Okay, so there's one possibility. What about the other side? Well, it's the same steps, isn't it? I've got the same thing on the left side, so I'm going to do the very same stuff. I'm going to add 20. So those cancel. I get 2x equals 54. I'm going to divide each side by 2, and I get the solution x equals 27. So those are my two solutions, okay? Either x equals negative 7, or, that's how we write or, x equals 27. And I could try those both in my original equation. They would both work, okay? How are we doing? Thumbs up, thumbs down, thumbs sideways. Where are we here? Okay, good, good. So This U is here just to remind us that we can't do anything inside the absolute values. We've got these absolute values that are off limits. So what are we going to do here if I've got an absolute value equation? Ellie, what's the first thing I'm going to do? Perfect, because you're isolating the absolute value. Good job. And in answer to your question, you are in.
All right, thank you.
So we add 11. Cancels the 11s. That's good. And then I've got 2 times my absolute value equals 0. Okay, that's a little weird, but that's all right. 0 is a number. We can deal with that. Emma, what do I do next?
Divide by 2.
Yeah, divide by 2. And you might be thinking, oh man, can I do that? Yeah, you can. You can divide 0 by 2. Everybody, what is 0 divided by any number except 0? 0, yeah. Okay, so then we get our absolute value isolated. We got it by itself, and it's equal to 0. So now we can look at, well, actually, let's look inside. Let's look inside. So if I take this out of there, what's inside is 3x plus 6. Now, normally we would say, okay, we're going to, whatever's inside, the 3x plus 6 has to equal the positive number outside or it equals the negative number. But 0 is the one number that has no opposite, right? The opposite of 0 is 0. So in this case, we only get one equation instead of 2, right? Now, this would be the case if we look back at our graph we had, actually right there. Look at the difference here. What's going on? Well, now instead of the line, the number on the other side of the absolute value being some positive number, it's 0. So if I graph the line y equals 0, doesn't that just look like a line on the x-axis, right? Y equals 0 is the same thing as the x-axis. And now notice what happens. I get the intersection. There's only one intersection instead of 2. So we're only getting one solution, okay? Oops. There we go. So I get one equation, whatever's inside. In order for its absolute value to be 0, it has to be 0 because the absolute value of 0 is 0. So I can just subtract 6 from both sides. So 3x equals negative 6. I divide by 3. And I end up with x equals negative 2. And could x be negative? Sure, x can be negative, right? That's no problem. If I plug negative 2 in for x, I'm going to get 3 times negative 2 is negative 6. Negative 6 plus 6 is 0. So everything in the absolute values is 0. The absolute value of 0 is 0. So I end up with 2 times 0 minus 11 equals 11. Well, that's right, because 2 times 0 is 0. Negative 11, sorry. So I end up with negative 11 equals negative 11. So my solution works. X equals negative 2. Okay, camera's on for a second. Everybody, just click them on and give me thumbs up, thumbs down, thumbs sideways. Got to know. Click those cameras on. Now listen, if you're not clicking your camera on, what am I probably going to think? I might suspect, and maybe rightly, that if you don't click your camera on, that you're not there, right? So you make sure you click those cameras on when I ask you to, please. Thank you. Okay, you can click them off. Thank you. Got my feedback. Okay, one more of these type. So what about this one now? I've got this absolute value. Would everybody agree here? I won't pick on anybody for this example. I'm trying to isolate the absolute value. So would everybody agree that that means I'm going to have to add 1 to both sides to get the absolute value by itself? And that's going to give me 3 times my absolute value equals -6. I could divide by 3 to cancel the 3's. And then I get my isolated absolute value equals -2. And if I really want to put the what's inside in there, okay, what's inside is a 2x minus 1, but I almost don't even have to do that because maybe somebody sees a big problem. Can anybody see a problem with what we came up with there? The absolute value of who cares equals -2. James, is that a problem? You see something wrong with that? Question is to James. James, are you there? Okay, Jasmine, how about you? Do you see something wrong with that? Give you a little hint.
The negative?
Yeah. Is that possible? Could I have the absolute value of something equal to a negative number?
Yes.
I can. I think what absolute value does. Didn't we say earlier that the absolute value of a positive is a positive, the absolute value of a negative is a positive, and the smallest output I could get from an absolute value would be the absolute value of 0 equals 0. The job of absolute value is to make things non-negative, right? If I input a negative number, it still comes out positive. So something's not right about that. Everybody agree? That's not possible. We can't get the output of an absolute value function to be negative, right? So then what do you think? Jason, what values of x, how would you answer this then? What values of x could make this happen? Could make an absolute value equal -2? What do you think? Jason Parker? Okay. And you're probably right in having a hard time with this because everybody, what's the answer? What would I write down for this? Anybody have a suggestion? If it's asking me what values of x could I plug in? No solution. Yeah, absolutely. It's impossible. There's no value I could ever plug in for x that's going to make the absolute value of something equal a negative number. So this answer is no solution. Now, if we didn't see that, if we just accidentally missed that negative sign and we did the problem, it's still going to blow up. It's not going to work, right? So we would say, okay, when we'd set whatever's inside, if we're going to try to solve this absolute value equation, whatever's inside, so 2x minus 1 would either equal the number outside, maybe you're thinking, or 2x minus 1 could equal the opposite, which would be +2. If I solve these, I guarantee it's not going to work. If I add 1 to both sides, those guys cancel. I get 2x equals -1 divided by 2. So x equals -1/2 is one answer. What about over here? If I add 1, I get 2x equals 3 divided by 2 and get x equals 3/2. Let's try those. If I plug those into my original equation, -1/2, 2 times -1/2 is -1, isn't it? -1 minus 1 is -2. So I have the absolute value of -2, which is 2. 3 times 2 is 6. 6 minus 1 is 5. So I get the result 5 equals -7. Didn't work. So that solution was a false solution. What about 3/2? I could do the same thing up here with 3/2. If I plug 3/2 in, 2 times 3/2 is 3. 3 minus 1 is 2. The absolute value of 2 is 2. So 3 times 2 is 6. Minus 1, I get the same thing. I also get the answer 5 equals -7, which is not true. So even if I did try to do the math gods are smart. They know it shouldn't work, and so we don't get solutions that work. But we didn't have to do that, right? The big thing here is we should be able to notice here in this step right here, this is the important one. If I end up with an isolated absolute value equal to a negative number, that's no solution, okay? You can just stop right there. It's got to be no solution. Okay, so what about this then? This is, how are we doing for time? Okay, we're fine. We'll get there. So last thing we talk about is what happens if we have an absolute value equal to something that's not a number, equal to something, an algebraic expression that has variables in it, okay? Well, this absolute value is already isolated. So then what are the things that could happen here? Whatever's in same rules as before, whatever's inside either has to equal the positive of what's outside, or what's inside has to equal the negative of the negative of what's outside, because the absolute value bars are making it positive, right? That's the job of absolute value bars. Oh, darn it. Come on. This stupid board. Right? That's the job of the absolute values, to make it positive. So it could either start off as negative or start off as positive. It's always going to end up as positive. So we get two equations out of this. Either whatever's inside is equal to the positive of what's outside, or, remember that's my symbol for or, whatever's inside is equal to the negative of what's outside. Everybody click your cameras on and give me a thumbs up, thumbs down on that one, right? Does that make sense? Even though there are variables there, we follow the same rules. Okay, good. Thank you. Thank you. Okay, so Calvin, what are the steps I'm going to follow to solve this equation? Questions to Calvin Ellis. Okay, what about Ashley? What am I going to do right here? How am I going to solve this? Questions to Ashley. How about James Savage? Oh, Ashley, okay, add 14 to both sides. Good. So we're going to add 14 to both sides, and that's fine to do. Let's look at this now. I've got x's here. That would work. Where do I want to maybe push the x's here, left or right? Everybody just point with your, in the camera. Which direction do I want to push the x's? I'd like to have a positive number of x's. So am I pushing them to the right or the left? Okay, yeah, I see it. Good, so we're going to push this way. Let's subtract 12x from both sides. So we end up with a positive number of x's over here, right? So I'm going to get 2x plus 4 equals negative 14. Now, what are going to be the two steps in order here, Josiah, to get the x by itself? What do I do first?
You add 4 to 14.
Add 4?
Yeah. Oh, subtract.
Subtract 4. There you go. Good. Subtract 4. Cancels the 4. Very good. So that gives me 2x equals negative 18. And then next step?
You divide 18 by 2.
Good. Okay. And then we end up with our solution. X equals negative 9 is one solution. Okay. On the other side, now what have I got to do here? I've got the negative of 14x plus 4. So let's see, Kyla, what do I have to do up here in this equation first, probably? What do I need to do with that negative? Distribute. Good job. So I distribute and I get the equation. I'm going to put a line in the middle so we separate these. I get the equation 12x minus 14 equals negative 14x minus 4. Good job. Okay, so then Liam, which direction do I want to push the x's? Left or right? You tell me. What am I going to add to both sides first? Questions to Liam. Add 14x. Good job. We're going to push the x's to the left. So those cancel. I get 26x minus 14 equals negative 4. I'm going to speed this up just a bit. Would everybody agree? I'm just going to get the x by itself, I'm going to add 14. So I get 26x equals 10. And then I'm going to divide by 26, right? So those guys cancel, and I get the solution. X equals 10 over 26, which I could reduce to, what, 5/13? Okay. Now, when I'm solving an absolute value equation that has x's on the outside, I have to check the solutions because I could get extraneous or false solutions here. So I'm going to show you a trick to do this. Okay, this is a great trick in Desmos. Man, I might run out of time. Gosh darn it. You can use the Desmos graphing. It doesn't even have to be the graphing calculator. But here's what you do. When I want to check solutions, I'm just going to set up functions. I'm going to set f of x equal to the left side. Write it in function notation. So f of x equals the absolute value, and that's just the key above enter, the vertical line. So the absolute value of 12x minus 14. Okay, and I'm going to make another function, call it like g of x. And that's going to be equal to the right side, which is 14x plus 4. It's all I've got to do if I want to see if these solutions worked. Negative 9, for example, is I'm just going to plug negative 9 in to both sides of the equation and see if I get the same answers. Okay, I can do that using my function notation. I can just do f of negative 9, and then Desmos is plugging negative 9 into f of x for me, and I get 122. If I plug negative 9 into g of x, so g of negative 9, look, I get negative 122. So what's that tell me? Is negative 9 a solution? What do you think? Thumbs up, thumbs down. Is negative 9 a solution? It's not, is it? Because when I plug negative 9 in, I got a different answer on this side of the equation than I did on this side. So negative 9 is a false solution. It did not work. When I plugged it in, it didn't satisfy the original absolute value equation. It didn't make it true. What about 5/13? Well, let's check. Desmos makes it really easy to check fractions. So I'm going to check 5/13 now. There's my other solution, right? So f of 5/13 gives me that weird decimal. G of 5/13 gives me the same weird decimal. So is 5/13 a solution? I got the same thing on both sides. That one works, doesn't it? Good. So 5/13 ends up being the only solution in this problem. The other one didn't check out. So in math, we would say that this was an extraneous solution. It didn't count. We only got one. That's it. 5/13. Okay. We're out of time. How are we doing on this? Everyone click your cameras on. We feeling like you got a decent start on this stuff? Okay, jump on this assignment today. Might as well get into it, before you forget it over the weekend. Why don't you jump in, and if you're having any issues at all, drop into my office hours. I'd love to help you. Okay? It's a great place to be. You guys all should want to be at my office hours. They're so much fun. It's just a math party every day there. All right. Hey, I'll let you go. Have a great weekend if I don't see you this afternoon.